Hi, good afternoon, everybody. Happy Monday. Hope everybody had a good weekend. Good Easter if you celebrate Easter. So today we are covering two sections again, 3.4 and 3.5. Both of these sections will be on exam 3 and the final exam. 3.4 is on finding roots of polynomials. And again, like the last couple of classes where we've had multiple sections to do within one class period, stuff for 3.4, we'll work these problems, and then 3.5, I'll put that information up on the board and make sure you guys know that as well. And then 3.5 is on complex numbers. So if we have a negative under the square root, how do we address that? So we get what's known as a complex number as opposed to real or rational numbers like we've been dealing with so far. So just sort of quick here from 3.4. If we have this polynomial, this is the form an x to the n plus a bunch of other stuff plus a 0 at the end. All of the rational zeros have this form, p over q, where p is a factor of the constant a0 and q is a factor of the leading coefficient, a sub n. So if we find all the factors of a sub 0, all the factors of a sub n, positive and negative for both of them, create these ratios. These are all the possible roots. Now, when we're trying to find these, we could have, 10, 12, 14, quite a few number of possible roots. And so one way that we can sort of trim that down is with the sign change rule. And so what we do is if we have our polynomial, whenever the sign changes, every time we count one of those changes, if we end up with, let's say, changes. So let me give you guys an example here. Let's say we have piece of x is x to the 5th minus x to the 4th minus x to the 3rd plus x squared minus x plus 1, let's say. So the first term is positive. The second term has a negative in front of it. So that was one sign change. We count that as 1. Next term is negative. Then we switch to positive again. That's 2. We switch to -3, switches back to -4. So this tells us that there's either 4 or we keep reducing by 2. So there's either 4 or 2 or 0 possible positive roots. So does that make sense to everybody? I know that that's always an issue for people, is this idea of how many possible roots or less by 2. So we have 4 sign changes, 1, 2, 3, 4. So the possible number of positive roots is 4, the sign changes that we had, and then just start decreasing by 2. So 4 or 2 or 0. Does that make sense to everybody? Any questions on that? Okay. So then if we plug in -x and simplify this, we can do the same thing, and that'll give us the number of possible negatives. And the shortcut is essentially whatever has an odd exponent, so 5, 3, and 1, change those signs from whatever they are. So this one was positive, so this would be a negative. X to the 4th is going to stay. X to the 3rd will change, so it was negative, it now becomes positive. X squared will stay the same. X to the 1st power would change. That becomes positive. And then 1. So this is P of minus x. If I plug in -x and then simplify this, the only thing that's going to end up changing is all the odd exponent terms, their signs will change. And so we do it again. But we start with negative, still negative, goes to positive. That's one sign change. And then it stays positive from there out. So we know that we only have one negative root. So for the possible positive, it was either 4 or 2 or 0. And for this one, it was just 1. So if I want to now start trying to figure out what are these roots, Well, I would start with the negative, because as soon as I find one of them, I'm done. I don't have to keep checking all the different possibilities because there's only one negative. So once I find that negative root, I'm done, and then I can just simply focus on all the positive roots. Does that make sense to everybody? Any questions on that? All right, I wanted to go through that to kind of buy us a little bit of time here in part, so I can sort of address a few administrative things. So first of all, hopefully you guys can now view your exam 2. So if you want to check again and confirm whether you can or not, but they had me change yet another setting on it. And so it should hopefully give you access to that exam to where you can see the questions, see the answers, and all that. So hopefully you guys can see your exam 2 now through Canvas. If not, let me know, and I'll keep working on this till eventually we can get this for you guys. Your exam 3, that is coming up in just over 2 weeks, on the 29th. And so we have this week that we'll be doing some material. We have next week that we're doing material, and then that's it. Then we're done learning material. You can see me. Okay, great. Thank you so much. I'm so glad to hear that. Yeah, so we basically have these 2 weeks of material, and after that, we're done as far as the new material goes. The third week, so 2 weeks from today, we'll have a review session like we did before the last exam. You guys will have that Wednesday, the 29th, just like before, the whole day to take the test. And then after that, it will be review week or study week. So we'll review the exam on that Monday, 3 weeks from today. 3 weeks. And then, okay, good. Glad to hear that, everybody. We'll have a review week, and then your guys' final exam will be on, was it May 9th? And so it's coming up here less than a month, and then all this craziness is over with. So I will, I'll give you guys, I'll probably start a discussion, and I'll just keep adding the different concept ideas to it. Maybe it'll include some of this. I'm not exactly sure yet, but I'll post them like I did with the last exam. And then I'll give you guys as well a breakdown what's going to be on exam 3. I'll have to start working on that. So I'll give you guys that information. So any questions on that, either viewing exam 2 or exam 3? Okay, good. Thanks, Taylor. So here's the next topic, and I got a bunch of email. I'm assuming that you guys are now registering for classes because I got a bunch of, I got some emails over the weekend asking me what sections I'm teaching in the fall. And I didn't respond to any of them in large part because I don't know. Generally, they don't even assign our classes until maybe mid-August. That's usually about the earliest. Sometimes with like mine, they'll sometimes do a little bit earlier. But what I can tell you is I will be so what they do, and with this quarantine thing and their limited hours they're working in the office, I'm sure that's part of the reason why they haven't even sent out the email. Usually what the department does is they send out an email, all the instructors, what classes do you want to teach, what days, what times, what's your preference, etc. They're pretty good about giving us what we ask for. And so what I can tell you is that I will be requesting so for Math 127, I'll be requesting sections 1009 and 1011. So this is Tuesday, Thursday at 8:30 a.m. And this is Tuesday, Thursday at 10 a.m. So I know right now if you were to go look at my UNLV, it's just going to say staff because they haven't started assigning anybody to any classes yet for the fall. Yeah, so this is fall 2020. the ones I'll be requesting. As I said, they're usually pretty good about giving us the classes we request. If for some reason this changes, so they don't give me these classes or they ask me to teach at a different time or whatever, I will either tell you guys if we're still in session here, or I will shoot an email to everybody and let you know. But for now, if it works with your schedule, if you want to enroll in either of these classes, it's likely that I'll be the teacher for these two, or conversely, if you don't like this format and you don't want me as your instructor, don't sign up for these two, because these will probably be the ones that I'll be teaching. Am I teaching summer? Good question, and the answer is I don't know. So historically, I do not teach in the summer, but with this whole quarantine thing, because I know that they're going to be doing the online classes like this for the summer as well. So maybe this year I'll do it because it'll be a little easier to do rather than, running a campus every night and things like that. So I may, but they haven't asked us that yet either. And I don't think they've started assigning the instructors for that. So what I'll do there, I'll look into that as well. And if I am going to be teaching summer school, again, I'll let you guys know either what I'm requesting or what they give me. But as of right now, I'm not teaching summer, and I'm not even teaching these, not officially, but it's likely that these will be the ones that I will be teaching. So, any questions on that? Got about 15 minutes, or 10 minutes, I guess, there of kind of prelim stuff before we get into any questions. So anything on that, either the Math 127 scheduling, anything as far as the 3.4 the question you guys had. Otherwise, we'll work some of these problems. Okay, so you guys had a question on number 8 and number 9, and this is the sign change rule problems. When would you let me? Honestly, Marco, I don't know. I don't have the answer to that. So they haven't, like I said, they haven't sent out an email yet. Yeah. When I find out, I'll definitely let you guys know. Or if I decide whether or not I'm teaching summer or not, I will let you know. Yeah, but right now I don't know. So I'll look into that tonight. I'll look at the schedule and sort of see what classes are open and if it's a schedule that I want. And if so, I'll ask them for it and we'll see. But yeah, as soon as I find out anything positive or negative one way or the other, I will let you guys know. All right, so number 8, we have 3x to the third minus 8x squared plus 4x minus 3. Yep, you're welcome. So, first thing it asks us is how many possible positive roots. So when we're looking for positive roots, we just leave the polynomial as it is and then count how many times does the sign change. So we were positive, it switches to negative, that's once. Switches back to positive 2, switches back to negative 3. So the answer for the possible positive roots would be 3, or you decrease by 2s. So 3 or 1. So what you would put in that first box is 3 or 1. Any questions on that? If this number would have been 8, then it would have been 8 or 6 or 4 or 2 or 0. It keeps going down by 2s. That's the possible number. Could be 3 or it could be 1. So then the next one, so we need p of minus x. So for the possible negative roots, so I change anything that has a odd exponent. So these two guys here. So this becomes negative. This one stays as it is. This becomes negative. That one stays as it is. So I start negative, negative, negative. It never changes, which means I have 0 possible negative roots for this polynomial. And so then the last box, and this is the confusing one, is the number of real roots. So how many real roots do I have? Well, for the positive ones, I have either 3 or 1. So the number, and this one has 0. So the number of real roots would be either 3 or 1, and they would all be positive. So it's how many real roots? 3 or 1 of them, and we know that they would all be positive roots. Does that make sense? Is there questions on that one? Okay. So number 9. Similar type problem. So we have x to the 4th plus x to the 3rd plus x squared plus x plus 7. So since you guys only had a few questions today, let's make this the attendance problem. So again, this will be the problem that you have in your Take It Out the Door notebook. So go ahead and try this one. Similar to the one we just did. The polynomial as it is, how many sign changes? If I change all the odd exponent terms, how many sign changes? And so then that leads me into how many real roots do I have, or possible real roots do I have? And I think I'll have to double check, but I think this upcoming Sunday, might be your last assessment. I don't think I wanted to do one right before the exam. I'll double check, but I think that might be your last one. And when you guys get done with this, just type in done so I know that you guys are done with it. Hey, Ginger's here today, everybody. Ginger, you want to come in? You want to say hi today? Come on. No? Ginger, come on. Hey, come on. Come on. So, here's Ginger today. Sleepy, coming to her office to sleep. Okay. Careful. Okay. You gonna sleep or you gonna leave? And she's gone. Everybody still working this, or are you guys done with this one? She was in a hurry to get out of here, I guess. She didn't want to be on camera today. You guys still working this one, or are you done? This one shouldn't be taking this long. Got me a little bit nervous if it's taking you guys this long. Okay. Okay, good. So it looks like you guys are finishing up. So for the possible positive roots. So I start, this is positive, stays positive, stays positive, positive. It never switches. There's no negative in this entire polynomial. So for the possible positive roots for this guy is 0. There aren't any. For negative, so I'm only going to change the terms that have an odd exponent. So just these two guys. So x to the 4 stays the same. This one becomes a minus. This guy stays the same. This becomes a minus. That guy stays the same. So now if I count the sign changes here, I start with positive. It goes to negative. That's 1. Back to positive 2. Back to negative 3. Back to positive 4. So for the negative roots, there's either 4 or 2 or 0. So how many sign changes do I have? And then subtract 2 until I hit either 0 or 1, and then you stop. So any questions on that? Did anybody not get that? Or need more explanation? You don't necessarily have to do this on these problems. I know some instructors don't even teach it, but I teach it and I emphasize it because it's going to help you out when you're trying. And this problem is actually a perfect example because we know there's no positive roots to this thing. So there's no reason for me to do synthetic division with either 1 or 7 on this because there's no way that it can even be a positive root. So it helps you either eliminate which one you don't even have to do, or if maybe this was a 1, you would look for the positive roots, and as soon as you find one of them, then you're done. So explain the negative sign change. Okay, yep. So the negative 0 values. Okay, so to find out the possible negative roots, we're going to, the long version of what we're doing is plugging in negative x for all of these. So negative x to the 4th plus negative x to the 3rd plus negative x squared plus negative x plus 7. But the shortcut, because anything that has an even exponent, so negative 1 to the 4th power is positive 1, so its sign is not going to change. Negative x to the 3rd becomes negative 1 to the 3rd power is negative 1, and then x to the 3rd. And this will keep happening the whole way. So anything that has an odd exponent, 3 and 1, those two signs are going to change. Everything else stays the same. So once I have this p of minus x, this is the one that I check the sign changes on. So it started as positive, went to negative, that's 1 change. Went back to positive 2, went back to negative 3, went back to positive 4. So there's, at most, there's 4 negative roots. but it also goes down by increments of 2. So 4 or 2 or 0. Because if I plug in, there's no negative x to plug into. Technically, it's x to the 0 power. So the constant is never going to change signs. It's only the variables that have the x, and the only ones that will change are ones that have an odd exponent, 1, 3, 5, etc. But the constant will never change from positive to negative or vice versa. Does that make sense now for both questions, Amber and Taylor? Does that answer your guys' questions? Okay. Okay, good. All right, so then the last part of this problem is, then what's the number of real roots? So there's 0 possible real roots, or there's 4 or 2 or 0 from the negative. So it's going to just be 4 or 2 or 0. Does that make sense there? We know from the negatives it has to be 4, 2, or 0. So we're going to end up with either 4, 2, or 0 real roots. And if they are real, they're all going to be negative. All right, so any questions on that? All right, and again, that was the attendance question, so just make sure that's in your ticket out the door notebook. And we'll still have to figure out how we're going to deal with that at the end of the semester, but we'll get there when we get there, I guess. So, okay. So, ticket out the door. But before we do today's ticket out the door, I want to go back to the ticket out the door on April 6th. So nobody asked me about this, which honestly concerns me a little. So either I guess you guys didn't do it, or maybe you did it wrong, like I did when I gave you the answer. But on April 6th, on number 2, you had r of x is equal to x plus 1 over x squared minus 4. And so for the y-intercept, I gave you guys the answer was 0, -4. This is not correct. Because y-intercept, we set x equal to 0, so we get what? 1 over 4, not 4 over 1. So the y-intercept should have been 0 and -1/4, -4. So make sure you go back in your ticket out the door, April 6th, problem number 2, y-intercept should be 0 and -1/4. Otherwise, if you're trying to do this one later, you're going to be like, how in the world is he getting -4? Because I had it wrong for you guys. So it should be -1/4. All right, so today's ticket out the door. So maybe what I'll start doing, like if we're look like we're going to get done early, like again today, is I'll go back and start looking at some review problems. So problems you might see on the final or on exam 3, and we'll use that time to work those. Actually, maybe, let's see. You know what, let's do that. Let's do that today. Let's work a couple review problems, and then I'll give you guys the ticket out the door. Yeah, I think that'll work. Okay, so then let's see. What do we want to do here? Well, let me look at some of these other ticket out the doors and get some ideas. All right, so let's call this review. Maybe we'll do like 15 minutes of review or so. I'll give you your ticket out the door. So let's say find the inverse whoops. Find the inverse of f of x is equal to x plus 1 over x minus 3. So that's part 1. Part 2 is state the range of f inverse of x in interval notation. So go ahead and try that one. Again, once you get done with that, just type done and if you have questions, okay, how do I do this? I don't remember. It's been a couple weeks, etc. Feel free to type them in. Try to answer them for you guys. So if you guys go back in your notes, remember how we do these. This one has like the 5 or 6 steps or 4 or 5 steps they do in order to find the inverse of a function that looks like that. Okay, good job, Jenna. And remember, on these problems, you can always check your answer by doing what? Plugging in what you think is the inverse into the original. Simplified, it should equal x. If it doesn't simplify to x, then you know that you don't have it right. So that's good. You guys got done so quick. So that's good news. Okay, good. We got there 1, 2, 3, 4, 5, 6, 7. So give you guys a couple more minutes and then we'll go. Okay, Alex. All right, so let's go ahead and work this. So let's do number 2 first. So why are we doing number 2 before we do anything with number 1? Well, let me ask you guys then. Give me your answers here. How do I find the range of F inverse? What is the range of F inverse? It's equivalent or it's equal to what? Not necessarily the answer, but just in words. So like this would be a good concept question. The range of F inverse is related to F of X in what way? Or is it not related at all? Yeah, exactly. So the range of F inverse is just the domain of F of X. So the domain of F of X is what? Well, I have this rational function. So domain, do I have any issues in the numerator? No, there's no square root or nothing. So my only concern is the bottom, x minus 3, cannot be 0, meaning x cannot be equal to positive 3. So any other value is fine, just not 3. So for this one, it would be negative infinity to 3 union 3 positive infinity. So we can do part 2 without even having to do any calculations really, or even knowing what the inverse is. If you can't find the inverse of this, doesn't matter. You can still figure out this as long as you can find out the domain. So any questions on that? Otherwise, I'll erase this and work on the inverse function here. All right, so for number 1, finding the inverse of this guy. So we do what? We put y is equal to this whole piece. And again, this has all those steps. The first step is multiply both sides by the denominator. So that cancels out, so I just get x plus 1 on the right and distribute the y over here, so xy minus 3y. And now you want to get all the x's on one side, everything else on the other. You move your x's at this point. If you move the xy over here and the 1 over, you'll get the negative answer of what I'm going to end up with. And I'll give you that answer, but it doesn't matter. Both answers are correct. So if I subtract x from both sides and add 3y to both sides, I get what? Xy minus x. These guys cancel out. And then over here, 3y plus 1. If you moved it the other way, you're going to end up with negative 3y minus 1 is equal to x minus xy. So these two are equivalent. It's just they're on opposite sides of each other. So now we do what? We factor out the x, so we get y minus 1. We do it over here, factor x, you get 1 minus y. So again, I'm working both of these at the same time, but you're only working one of these. So this equals 3y plus 1 divide everything by y minus 1. So from this one, and then change out all the x's and y's, tells us that f inverse 3x plus 1 over x minus 1. Now over here, if you divide everything by 1 over 1 minus y, and then switch it out, so I'll put or, these guys are equivalent, change out the x's, you get negative 3x minus 1 over 1 minus x. So either of those answers are okay. You move the x over to this side and then do it, you'll end up with the first one. If you move the xy over to the right, then you would end up with the second one. But again, they're equivalent. They're equal to each other. So as long as you have it one way or the other, you'll be okay. So any questions on that one? Finding the inverse of a rational function and the range of the inverse function. Okay. So our next review problem here. So divide p of x is equal to 3x to the fourth minus x plus 1 by d of x, which is equal to x minus 2 in two parts. So what is q of x? Part B, what is r of x? So go ahead and do that one. Divide that guy out. You can do it long division. You can do it synthetic division if synthetic division will work. Do it whatever method you want. So go ahead and try this one. Again, once you get done, let me know. If you have questions, let me know. And after this one, I'll give you guys your ticket out the doors. They're a little bit longer today, I think. And so I'll just keep planning on doing this. If you guys don't have a lot of questions from the homework and it looks like, we'll end up with a fair amount of free time after, I'll just start doing practice problems, get you guys a bunch of review problems. So like these last two problems we did, these problems are going to be on exam 3 and on the final. So you should know how to do these types of problems. Good question, Jenna. I'm not sure yet. So if people are still in Vegas, I'm hoping that we can at least start meeting face to face with people. So what I'll probably have you guys do is just drop them off. If not, and I guess even if you're nervous about still interacting with people. So say for you guys, for you and Cassidy and Billie Jean, anybody that's not in Vegas, what I'll probably do is just have you scan in your pages and then shoot me a PDF file or something, and then I'll check it over that way. So that's probably what I'll do. And then again, if someone's nervous about leaving their house still, then they can probably still do that same option. I just don't want 200 emails of everybody sending me their ticket out the door. So I'd rather just have you guys drop them off and I can check them over and then give them back to you. But we have to see how it goes. So I'm hoping that by May 1st, all this nonsense is over. If anything, I wish that businesses would kind of all get together and say, all right, government, you have till May 1st, that's your deadline, and then we're all opening up whether you want us to or not. So you can't arrest and fine everybody. So if everybody just opens up, what are they going to do? But that's me. So, but yeah, so we'll see. Hopefully, as we get closer to the end of the semester, then I'll let you know. But for you guys anyhow, since you can't exactly meet me on campus, yeah, I'm guessing you guys probably in the fall, I would assume. So for you guys, it would probably just be, scanning them in so if you guys even want to do these on like loose leaf paper, if it'll make it easier, or if you have a tablet and, if you're doing them on a tablet and you can save it that way as a file or something, that's okay too. But some electronic fashion, I guess, is how you guys will get it to me. Okay, Billie Jean. And everybody else, once you get done with this one, let me know. We'll go through it. All right. So you guys are getting this finished up. All right, so with this one, we can do it by synthetic division because this is a minus C. And so in this case, remember, it's the opposite of what you see. You see minus 2, so positive 2 is going to go on the outside of our synthetic division method. And then we need the coefficients, and anything that's missing, we need a 0 for a placeholder. So I start with x to the 4th. There is no x to the 3rd. There is no x squared, x, and then 1. So this is what your setup should look like. So any questions on this before I start the synthetic division process? All right, so the process is I bring down the first number, and then we're just multiplying and adding, multiplying and adding. So 2 times 3 is 6, added is 6. 2 times 6 is 12, added is 12. 2 times 12 is 24. Negative 1 plus 24 is 23. Multiply by 2 is 46. 46 plus 1 is 47. So my R of x is this last guy right here. So for the second part, the answer is just 47. For Q of x, these are the coefficients of the polynomial. I started with x to the 4th, so I start with x to the 3rd in my answer. So 3x to the 3rd plus 6x squared plus 12x plus 23. That's the answer that you should have for Q of x and R of x. So any questions on that one? All right. So before we get into the ticket out the door, because looking at one of the ticket out the door problems reminded me that I didn't give you guys the notes for 3.5. And there's a couple important things from this. So first of all, it's about complex numbers. And complex number has the form a plus bi. The a is the real part, and the plus b is the imaginary part. We don't include the I when we're talking about the imaginary part. So we would never say that 3i is the imaginary part. It's just 3. The The I is our indication that this is the imaginary part. And I is equal to the square root of -1. If I square this, square both sides, I squared is what? I squared becomes -1. So anywhere that I ever have an I squared in a problem, I can substitute it out for a -1. And then the last part here is complex division. So for example, if I have 3 plus I over 2 minus I, this is one complex number divided by another complex number. And so if the question said, what's the real part and what's the imaginary part, I don't just separate these off like, oh, 3 divided by 2, that's the real part. And 1 divided by -1 is -1, so that's the imaginary part. That's not how you do that. If you do that methodology, it's going to be wrong. So complex division, the process is that we multiply the numerator and denominator by the conjugate of the denominator. So the same way that we rationalized expressions with a radical in the denominator is the way that we divide complex numbers. So in this case, I would multiply everything by 2 plus I and 2 plus I. Then I would FOIL the bottom and get an answer. And I would FOIL the top and get an answer. And once I have that, then I could split it up and say, okay, this is my real part. This is the imaginary part. But you can't figure it out right from the start. You need to multiply by the conjugate. That will generate what's the real part and what's the imaginary part. Because otherwise, this is just saying, what's this number divided by that one? It's not going to be as simple as just say this is the real, that's the imaginary. So any questions on that? Again, you guys didn't have any questions from the homework, so I'm assuming that maybe you didn't have, hopefully you didn't have problems with it, but all right. So let me give you your ticket out the doors then. So the first one is find the roots of P of X is equal to 2x to the third minus 5x squared minus 6x plus 9. And number 2, solve for x. We have 2x squared plus 2x plus 1 is equal to 0. So go ahead and try those two. Again, once you get done, let me know. Once a few people have it, I can start putting the answers on the board. But you guys have about, about 20 minutes to try to work these. So see what you can get. If you do have questions, just ask me. I'll try to answer them for you before we leave here. Okay, Shannon. What'd you get for your first answer, Shannon, for number one? All right, so when you guys get done, just for the first one, I guess, give me your first answer. Second one, I guess you can try to type in the answer as well if you want. Let you guys know if you got it right or not. Yep, that's right for number one, Jenna. That's right, Jenna. You got them both. Yep, you're welcome. So if you're leaving, Jenna, have a good day. We'll see you Wednesday. Yeah, Taylor. So that's one of it. So -1 plus I over 2, and then -1 minus I over 2. So you'll be using the quadratic formula. You should end up with two answers. Okay. Hooey hooey. Yeah, it's hard with this. One of my 127 students asked me or told me about something that I guess can let you guys like talk back and forth. I don't know if it's like an add-on to YouTube, if it's a different platform. So I asked him about it. I haven't heard back from him, so I'll ask him during tomorrow's class. So I haven't heard back yet, but that would be ideal. Then you guys can just talk it out, and it's a lot easier to tell me verbally than trying to write it. So. But yeah, so it'd be -1 plus or minus I over 2. Yep. Yeah, it certainly would. I've been using Zoom a little bit for like department meetings, and that's nice. I don't know how well it would work on here. I guess it would because um, I could still have just my screen as this when I'm talking, and then when you guys talk, it'll just switch it off. But What's your question, Ahmad? What do you have a question on? Which class are you in, Ahmad? Ahmad, which class are you in? Anybody else finishing up? Need me to? So it should be -3/2. Otherwise, you have it. Yes. Yeah. So for number one, x is -3/2, 1 and 3. And number two is -1 plus or minus I over 2. So again, you guys don't have to leave or log off, just so if you are getting the answers and you want to double check it, those should be the answers that you have. All right, you're welcome. See you on Wednesday. Wear plenty of sunscreen. Thanks, April. You too. See you later. All right, Amber, Taylor. See you guys on Wednesday. All right, Alex. Have a good one, you too. All right, Shannon, have a good day. We'll see you later. All right, so it looks like we're down to the last couple here. Anybody that's still on, you guys need help, or if not, I guess I will shut down the stream and see you guys on Wednesday. All right, Mary, see you later. Have a good day. All right, we'll see you guys later.